Hey everybody, thanks for watching this video here on special right triangles. I'm going to show you where these right triangle shortcuts come from, and that's going to be the first of two videos that I'm making about this topic. The second one will just have some harder examples in it, all right? Well, this video really is about some shortcuts, some extremely useful shortcuts. These shortcuts will help you in your geometry and your trigonometry studies later on. We'll do a little bit of trigonometry this year, of course, but trigonometry is something that you will study a lot as you take more and more higher math classes, and the shortcuts in this video are going to be useful for a long time. You'll get a lot of mileage out of these shortcuts about special right triangles. As I mentioned, this video will have kind of some easy examples also. And if you want some trickier examples, ones that make you think a little bit harder, just check out the second video on special right triangles. All right, well, let's take a look at the very first shortcut that I want to show you today, and that is the 30, 60, 90 right triangle shortcut. Well, it comes from a shape that you're probably pretty familiar with. It comes from actually an equilateral triangle. As you know, an equilateral triangle, all three angles are the same measure. They're all 60 degrees. Well, if you take one of those 60-degree angles, divide it in half, you are creating two congruent right triangles. Each of those right triangles has angles of 30 degrees, 60 degrees, and 90 degrees. And it's an equilateral triangle, but one of those sides has been cut into two equal parts. So when you take a look at one of those right triangles, kind of separated out there, right away you see one of the two shortcuts that I wanted to show you today. That is that the short leg is always half as long as the hypotenuse. That short leg was one of the three sides of the equilateral triangle, but we cut it in half, so now it's only half as long. The hypotenuse now is still one of those sides of the equilateral triangle, and so it's twice as long as that shorter side. And in fact, that is the first shortcut. The hypotenuse of a 30, 60, 90 is always twice as long as the shortest leg. That shortest leg, again, is opposite the 30-degree angle. So check out that picture there for a second. Make sure that you can sort of understand where all that stuff comes from. Well, what about the third side, though? All right, the third side, or the longer leg, the one that's opposite the 60-degree angle, how do we write an expression for that? Well, let's take a look here. All we're going to do is, well, I think I'll call it h for height, and I'm going to write the Pythagorean theorem out for that right triangle. That says that the leg squared plus leg squared equals hypotenuse squared. So I'll say h squared plus x squared equals, in parentheses, 2x squared. Note those parentheses there. They are really important. A lot of people forget about them. But what we're doing is squaring the entire hypotenuse length, which is 2x. So if you take that equation right there, what we're going to do is solve that equation for h. That will give us an expression for that third side, the longer leg, in terms of x. So this is an easy thing to go through. I think if you're familiar with basic algebra stuff, you don't have too much trouble with this. 2x squared is 4x squared. And so if I subtract x squared from both sides right there to get the h by itself, I get h squared equals 3x squared. Okay, well, to solve for h, all I'm going to do is take the square root of both sides. So I have h equals the square root of 3x squared. Well, that can be simplified a little bit, right? The square root of x squared is simply x, and so I can rewrite that as x times the square root of 3. Now, we're kind of ignoring the whole plus minus bit that we do sometimes when we take the square roots in an equation, or the absolute value things we sometimes do. It's sides of a triangle, so we don't really have to worry about those things here. So that actually is the second shortcut that I wanted to show you today, that the longer leg of the right triangle, the one opposite the 60-degree angle, is always equal to the short leg times the square root of 3. So there's your two shortcuts for the 30, 60, 90 right triangle. Let's show them in this little diagram here. So that's a picture right there. This is how it's usually presented in math books. There are other ways, putting the variable x maybe on the hypotenuse, but then that gets a little bit more complicated. So this is usually how it's done. And so let's take a look at a couple of examples. Let's say I have a 30, 60, 90, and I know that the hypotenuse is 12. Well, the other two sides are now really easy to figure out because the short leg is just half as long, so that would be 6, and the longer leg is 6 times the square root of 3. Voila, we're done. Very easy. What about another one? Let's say we have the shorter leg given to us as 3.4. Ooh, that's maybe a little bit harder of a number. But no, it's not harder number. All you do is double it for the hypotenuse, and you multiply it times the square root of 3 for the longer leg. That's it. Make sure that when you see this, that you see really how simple it really is. All you're doing is taking the number for the side length of the shortest leg and multiplying that times the square root of 3 for the longer leg. That's all there is to it. Voila, you're done. All right, let's take a look at the other shortcut, the 45-45 right triangle shortcut. And it also comes from a different shape, one that you're also very familiar with. It comes from a square. If you take a square, all four sides are the same length, and if you divide that square diagonally, you get two 45-degree angles. And so that's where our 45-45 right triangle comes from dividing a square in half. Well, as you know, a square has two equal sides, and actually that right away, again, is the first shortcut, that the two legs of the 45-45 right triangle are congruent. It's an isosceles right triangle, in fact, because of that. And so it's, believe it or not, it's one of the easily overlooked facts about this. The two legs are the same length because it comes from a square. Well, what about the third side, the hypotenuse? Let's go ahead and do the same thing that we did before and give it a variable and use the Pythagorean theorem to solve the equation for that side in terms of x. Look at the algebra there that I set up, kind of sped through it a little bit faster this time, but the same thing really happened. I took x squared plus x squared equals c squared. I solve that and I get x times the square root of 2 equals the hypotenuse, and that's the other shortcut. The hypotenuse of a 45-45 right triangle is always equal to the leg times the square root of 2. All right, so let's take a look at that one now with a couple of, like I say, easy kinds of examples. There's the picture, the classic presentation of the 45-45 right triangle there, x, and x root 2. And let's say I have a 45-45 right triangle. One leg is 7. Well, that means the other leg is 7, and the hypotenuse is 7 root 2. It's that simple. There's really not a lot going on here. Let's try another one. Got a hard number now. Square root of 5 for one of the legs. Oh, it's not really that hard of a number, right? Because the other leg is the same. It's an isosceles right triangle. So the other leg is going to be the square root of 5. And now to find the hypotenuse, I have to take the square root of 5 times the square root of 2. Well, that's not so bad. You've practiced this probably a few times. All you do is multiply those two numbers together and you get the square root of 10. Voila, you're done. All right? So even with hard numbers, this process is very consistent and it's not that hard, really. Let's try one where the hypotenuse is the square root of a number. Let's say the square root is 6. Well, look at that previous example that we just did. Notice the relationship between the hypotenuse and the two legs. Look at that, okay? Well, I bet you could already figured out how long the two legs are. They are both the same length as in other words, they're congruent, and they are both square root of 3. All right, just to kind of summarize here, these two right triangles, this again is the kind of classic presentation of how these triangles, what the ratios between the sides are. And your job, dear student, is to start to memorize these. You will get a lot of mileage from memorizing these two shapes. We'll give you plenty of practice with easy numbers and with hard numbers so that you know the process 100%. And once you do, this shortcut will change your life as a math student. All right, so there you go. Thanks for watching. Watch it again if you'd like, or be sure to check out the other video that I will post that has some, I would call them trickier examples. It's the same process, just with numbers to make you think a little bit harder. Okay, thanks again. Be well, everybody. Bye-bye.